1.6 is about least common multiples, and we haven't really talked about multiples yet much this year, but we're going to start by writing down that multiples are numbers you get when you multiply a certain number. So you can kind of hear with the word multiple that idea of multiplying. And for instance, if you're looking at the number 3, then the multiples that you get when you multiply 3 by other numbers are 3, 6, 9, 12. And multiples can actually technically go on forever because you can multiply by any number and you'll always get a bigger number, which would be considered a multiple. So as we've been talking about factors and now we're starting to talk about multiples, these two can get confused pretty easily. So this is just a fun little visual. You do not have to draw the chart if you don't want to, but you might want to make a quick note from down here about the difference between factors versus multiples. So any number that you're starting with, if you're thinking about factors, factors are all the numbers that can go into that number. And if you're thinking about multiples, multiples are all the numbers that can come out of that particular number. So we talk about the factor ninja here who's chopping up products. So they're always going to be smaller than the original number you're trying to talk about. And then multiples are always going to be bigger than the original number, or at the very least they're going to be the same as the original number. So just a fun little graphic to try to keep them straight. Another vocabulary word we're going to be using a lot is least common multiple, which we usually call LCM, and that's the least or the smallest multiple two or more numbers have in common. And again, you'll mostly hear us call it the LCM. For example 1, we're going to practice finding the least common multiple using lists of multiples. And the question asks us to find the least common multiple of 4 and 6. So the first thing we're going to do is list the multiples of each number. And the multiples of 4, again, are everything that you get when you multiply 4 by something else. And we always just kind of start at the first possible number. So in this case, it's going to be 4, and then 8, 12, 16, 20, 24, and the thing about multiples to keep in mind is that they can actually keep going on forever. So at the end, we just kind of put dot, dot, dot to remind us that that list can continue on. And I usually just start with a few multiples at a time. So I started with, let's see here, about 6 to begin with. Anywhere between 5 and 10 is a good starting list. And then we're going to go ahead and do the same thing for the multiples of 6. So 6, 12, 18, 24, and 32, and we'll just kind of say dot, dot, dot there. And then to find the least common multiple, again, we're going to look for anything they have in common, and we can see that both of them have a 12 on their list, and they both have a 24 on their list, but since we're looking for the least common multiple, then we're going for the smallest one, and the first one that they both have in common, or the smallest one, is 12. So then we say the LCM, or least common multiple, of 4 and 6 is 12. That's the first one they have in common. Here are a couple of on your own problems, and remember, part of being able to do this is making sure you follow the directions that are given. So in this case, you're finding the least common multiple of the numbers using lists specifically. In the next example we do, we're going to talk about another way, but just keep remembering to look out for the directions, and if they don't tell you a specific way to do it, then you can choose. But if they do say they want you to do a specific way, like using lists, then you want to make sure you do that. For the answers to the on your own questions, I went ahead and made the lists again. And with multiples, again, it can be a little bit tricky because the lists can go on and on and on. So one trick that might be helpful, and because I had the lists already drawn, you couldn't necessarily see it, sometimes it's helpful to actually start with a bigger number and do maybe 5 or so multiples out of that bigger number, and then do the smaller number so that you can do as many as it takes to start noticing any patterns. If you start with a smaller number, you actually go for quite a while and you're not really sure where to stop. But that's just something that you can try along the way, see if it helps you out. Otherwise, go ahead and look. These are your 3 answers. So the least common multiple of 3 and 8 is 24, least common multiple of 9 and 12 is 36, and the least common multiple of 6 and 10 is 30. Example 2 has us finding the least common multiple using prime factorization. So we're going to start with factor trees again, just like we've done the last couple of examples, and we're going to go ahead and just make factor trees, and then we'll stop and look at how it's a little bit different to find the LCM than it was when we were finding greatest common factor. So here are our factor trees. We've got factor tree for 16 and for 20. And again, we've talked about how you can start with any factor pair that you want. So you could have done 4 times 4 here, or with 20 you could have done 10 times 2. Any factor pair works because you're going to end up with the same result. And once you get it down to all your prime numbers or your prime factorization, then we're going to go ahead and list those prime factorizations out so that we can start looking at some things they have in common. Oops, and at the end of this one, I forgot to actually put the step numbers on there, so make sure you add those actual steps into your notes, please. And we were just running out of space, so you don't have to copy down the factor trees again or the prime factorization if those are written in a place where you can find them easily and they don't have a lot of extra writing. If you are going to copy something down again, just do the prime factorizations. And we're getting to step 3 here now. So the next step after you've done your prime factorizations is that you're going to circle each different factor where it appears the most number of times. So let me show you what that looks like. So up here we have 2's, and we have 4 of them in this line and only 2 of them in this line. So we're going to circle the 2's where they show up the most, and then we're not going to circle them down here where they've because we already have some 2's, but then we do have a 5 down here that we don't have anywhere else, so we're going to circle that one too. Last step is going to be to multiply all of those circled factors together, and this will give you the LCM, or the least common multiple. So in this case, all of the circled factors that we had were 2 times 2 times 2 times 2, so I wrote those there, times 5, and you can group these if it makes it easier, or you can just multiply if you feel like doing the side math. So 2 times 2 is 4, and another 2 times 2 is 4, so we'll multiply 4 times 4 together, which is 16, times 5, and we get a product of 80, and so that means that the LCM of 16 and 20 is 80. And you'll want to remember that with least common multiple, you're always going to get a number that's at least as big as your biggest number and bigger than both of the numbers. So in this case, 80 is bigger than both 16 and 20. Because this is new and it's a little bit different than greatest common factor and we want to make sure that we can keep them apart, we're going to do one more example together. So this time we're going to find the least common multiple of 14 and 18 using prime factorization again. So we've put together a little factor tree for 14, just 7 times 2 because those are both prime. And then 18, we did 9 times 2, and then 9 can be broken down into 3 times 3. And then we're going to go ahead and write out those prime factorizations. And once we have those prime factorizations written out, then we're going to look for any different factors wherever they show up the most. So I can see that I have a 2 here and a 2 here, and it really doesn't matter which one I circle. So I'll go ahead and circle this 2. And then I have a 7 that shows up here, and then I have 2 3's. So then to find the least common multiple, I'll multiply 2 times 3 times 3 times 7. And again, if you feel like grouping it, you can. You can do 2 times 3 is 6 times 3 times 7. Or if you wanted to group your 3's together, you could do that. And then you'll take a second to figure out that 6 times 3 is 18. And then you'll do some side math to figure out what 18 times 7 is. And you should come up with 126. So the least common multiple of 14 and 18 would be 126. And now you're going to try a few on your own problems. Remember in this case to do the prime factorization method that we were just practicing for problems 5 and 6. And these come right off of page 38 in big green. And again, for the answers, I've gone ahead and shown you all of the work that goes along with it, so you can see the factor trees and make sure that your prime factorization matches. So here's your prime factorization for each one, and then I've circled any of the factors where they come up the most, and then I've written those out to multiply. I did do some grouping, but again, if you choose not to group and you just multiply and do the side math, that's fine too. But for number 5, the least common multiple of 28 and 36 should be 252. And for number 6, the least common multiple of 24 and 90 is 360. So you can see the numbers get pretty big pretty fast. Example 3 has us finding the least common multiple of 3 numbers, and the good news for this is it's no different other than you just add in an extra factor tree and you keep doing the same thing. So I did a factor tree for 4, for 15, for 18, and then I wrote out my prime factorization, and now I'm going to look for any new factors wherever they show up the most. So I have 2 2s on this list, and then I can see I've got a 3 here, but I also have 2 3s down here, so I'm going to circle where I have 2 3s, and then I have a 5 that's different, and then I'm going to go ahead and write those out. And once you write those numbers all out, the 2 2s, the 2 3s, and the 5, then again you can just multiply them straight across, and they will get big fast, so you will have to do some side math. I choose to group them, so 2 times 2 is 4, 3 times 3 is 9, so we'll do 4 times 9, which is 36, and then do some side math to figure out that 36 times 5 equals 180. So the least common multiple of all 3 of those numbers, 4, 15, and 18, is 180. For the real-life application in example 4, they say a traffic light changes every 30 seconds and another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? And we can solve by finding the least common multiple of 30 and 40. Now, it doesn't technically say how, and it's a word problem, so you can choose. You can do by listing or by prime factorization, so you could look back to examples 1 or 2 and figure it out. I'm going to show you the listing way, that's what the book shows, but if you want to see the factor tree way, just let me know. So your multiples of 30, you can start out with 30, 60, 90, 120, and again, those can keep on going, but we'll stop there. And your multiples of 40 are 40, 80, 120, and as soon as I see it, I could technically stop. I happen to write the 160, but once you see that, you can see that's your least common multiple, so that means, according to this question, after how many minutes will both lights change at the same time? Again, B, that we would say that in this case, it would be, we do have to keep in mind that this was written out in seconds, so 30 seconds and 40 seconds. So these are technically in seconds, and the question did ask for the answer in minutes. So we do have to make sure that we remember that there are 60 seconds in every minute. So we would take 120 seconds divided by 60. Kind of remember those zeros can get canceled out, and 12 divided by 6 would be 2. So then we just tuck your, or excuse me, I stuck a 0 on there when I didn't mean to. You would put your 2 on there, and then you would say that that is every 2 minutes. Or in 2 minutes, the lights will change again. Alright, this time your practice problems are coming from Big Green again. You're going to be doing pages 40 and 41, 8 through 18, and this time notice we're doing the evens. We've been doing odds a lot lately. We're going to do evens this time, so remember to do just the evens from between 8 and 18. And then you are going to do problem number 19 and 20, and then problem number 22 also. Remember to do these in your math notebook and to show all of your work.